Hi, my name is Nicole Beer. I'm a graduate student at Morningside College. I currently teach 8th and ninth grade PE at Johnston Middle School, which is in Johnston, Iowa. I wanted to research the effects of heart rate levels during exercise on 8th and ninth grade student IEP math probe scores. Why me? I'm very passionate about exercise and increasing academic achievement through that, so I wanted to test the use of physical activity as a math intervention. My problem statement is that there's been a steady plateau or decrease in math scores in the United States from 2009 to 2017. This was founded by the NAEP studies in 2013. There's a need for additional math intervention, as well as that my building in particular has shown low math Iowa assessment scores in the last several years. So starting with the review of the literature, what I found was that there's overall a lack of math interventions, and Ribner et al. 2017 found that students receiving interventions are still continuing to fall behind. So he factually found that they're only improving by 33% with interventions in place in elementary schools. Secondly, there's students are still scoring below proficient due to lack of intervention. Cotting et al. 2016 founded this. There's been a failure to intervene early in a student's education, and that has led to 67% of 8th grade math students scoring below proficient. And students who fail math in 6th grade are 60% more likely to actually drop out. Another review of some literature that I looked at was that there are correlations between physical activity levels and math. Philip, Hannon, and Castelli, 2015, founded this. So they've actually looked into some educational research as well as psychological research that supports that. Some impacts of this issue is that impacts of problem solving in major math concepts. This research was done by Azoy and Adaman in 2009. They found that a student who can't exactly examine a problem or arrange a math operation correctly, choose the best way to solve the problem, and actually carry out the operations, those students are likely to not have the ability to overall problem solve. Secondly, there's an impact of math and college readiness and success by Logue, Watanabe, and Douglas in 2016. They found that about 60% of first-year college students are unprepared for math courses. Third, we have impacts of math and additional remediation during college. So the number of students receiving remediated math lessons surpasses any content needing remediation in college. And McCormick and Lucas, 2011, founded that. Lastly, there exercise and academic achievement. There are exercise procedures that lead to academic achievement. So students can show an increase in academic achievement, but the research that I saw found that there were some gaps in the procedures and methods. So going off of that, the gaps that I did find, a lot of the research that looked into exercise as an academic intervention was that exercise was usually measured very objectively, and it is hard to measure intensity of exercise. There was other studies that lacked the individualization of exercise measurements. For example, heart rate monitors were used, but they weren't individualized to the student's fitness level. Physical activity levels were looked at in and out of school, or just one of them. And then lastly, just the subjectivity of measuring exercise. Timing of physical activity followed by the dependent variables also differed in a lot of the research that I looked at. And in my opinion, it does make a difference on when that dependent variable is given after the physical activity. My purpose statement includes that I wanted to identify the relationships between physical activity and special education student math probe scores of 8th and ninth grade students with IEP math goals measured by the AIMS test. Physical activity levels were measured by the IHT heart rate monitors. Math probe scores were measured by AIMS. I hypothesized that students who exercise vigorously for 15 minutes while keeping their heart rate in the red zone before a math probe assessment will achieve higher scores or show self-improvement than students who do not exercise vigorously for 15 minutes prior to a math assessment. My independent variable was exercise, and that was done throughout 3 different phases. Phase 1 was no exercise, phase A was no exercise, phase B was moderate exercise, phase C vigorous. And again, that was measured by the IHT heart rate monitors. My dependent variable was the Algebra Assessment Instruction Meeting Standards, or AIMS math probe scores taken by IEP math students. This was a quantitative research study used to determine the impacts of exercise as an academic achievement. The results of the study could be used to assist schools in better scheduling PE classes before student math classes. My results confirmed movement is essential in student success. So the methods and how I went about this was that I had 10 total participants that were math special education students. There were 6 females and 4 males. 3 8th graders and 7 9th grade students. 66% of the 8th grade students received free and reduced lunch, while 57% of the 9th grade students received free and reduced lunch. 100% of the 8th graders were Caucasian. 71% of the 9th graders were Caucasian. 14.5% were African American, and 14.5% were Hispanic. I did utilize permission slips before starting my treatment, so I received 10 permission slips for my research. I use the Fitnessgram Pacer test, and that is used to determine target heart rate zones for heart rate monitors. So this every student's fitness level is different, and the Fitnessgram Pacer test helps PE teachers determine those fitness zones and the target heart rate zones. I also use the Algebra Assessment and Instructions Meeting Standards, or AIMS math probes. Interactive Health Technologies, or IHT Spirit System heart rate monitors were utilized. There's also a computer program system that comes with that, which reports out on the minutes of how long the student was in a particular zone, and it individualizes the student heart rate zone and then shows data of their heart rate during exercise. The treadmills used were Precor 946i models. This is an example of what is shown after students scan in their heart rate monitors. So when I refer to phase A, students being in the blue zone, if you refer to the image on the far right, I had their heart rate in that bottom blue zone for 20 minutes. Phase B, they were in that yellow zone for 20 minutes. Phase C, in the red zone for 15 minutes. The AIMS math probes were reliable and valid. All of the questions aligned with the Common Core state standards. There were 112 reliability tests on the AIMS probes, and there was a range of scores within tests that concluded 99.1% accuracy. The validity results included the majority of the validity tests ranged from 47 to 58%. So moving into my procedures, again, I used an ABC design model. The same participants were looked at throughout each of the phases, so only their data was only compared to themselves. Again, the 3 phases of exercise modalities included no exercise, and students were to be in the blue zone for 20 minutes, followed by their math skills class. During phase B, they were moderately exercising on the treadmills. They needed to be in the yellow zone for 20 minutes, followed by their math skills class. And then lastly, during phase C, they were vigorously exercising for 15 minutes on the treadmills and in the red zone on their heart rate monitors, followed by their math skills class. The AIMS math probes were given to students prior to their treatment and then also at the end of each phase. And again, they then attended their math skills special education math class following their PE class. So there was a dependent sample t-test used for statistical analysis at the end of each phase. Moving into my results, at the end of phase A, math probe scores actually decreased Remember, students were not exercising during this phase. The t-score was 0.642, p-value was 0.537. That showed a negative 7.2 decrease. Their mean scores went from 11 to 10.2, as shown in figure 1 here. From phase A to phase B, there was an increase in their scores. So the t-test showed a negative 0.709 with a p-value of 0.496. That was a 5.8 increase in math probe test scores. So they went from 10.2 to 10.8, as shown here in figure 2. And then lastly, during phase B to phase C, this was when they were in the red zone on their heart rate monitors, vigorously exercising for 15 minutes. There was significant results at the end of this phase, and the t-score showed a negative 5.449 with a p-value of 0.001. This showed a 24.9% increase in math probe test scores. So they went from a 10.8 to 13.5 while they had vigorously exercised prior to that math class. So the t-test showed a p-value of less than 0.05 in this table here, which suggests math probe growth due to vigorous exercise before the assessment was not due to chance. 15 minutes of vigorous exercise is an effective strategy to improve AIMS math probe scores. Looking at the connections to theory and past research, so I utilize the social cognitive theory within my research, and this looks at individuals learning in social situations by observation or self-observation. So the relationship between exercise and cognitive functions was also included within this, and then it also includes maintenance of health, self-efficacy, and self-regulation, according to Connor and Norm, 1995. As for past research, a lot of it supports exercise as an academic intervention, focusing on intensity levels. So Rady and Hagerman founded that in 2013. Alvarez Bueno et al. 2016 found that physical activity impacts cognition when movements are incorporated, as well as goal setting, self-regulation, and critical thinking. Some implications for this study include, for students anyways, that exercise causes students to feel motivated and perform better on math probes. Some implications for teachers as well as PE teachers. Small teacher to student ratio can benefit student performance. For PE teachers in particular, lessons taught with tougher bouts of physical activity during class can have a positive impact on student math probe scores. And then lastly, for districts, they could look into adjusting or changing their scheduling so that PE curriculum better benefits students. Some limitations to the study were that I only had 10 participants, 6 females, 4 males. There was some scheduling issues. There were a couple of students that did not have their math skills class immediately after PE, but they did a couple of class periods later. I did not track their exercise outside of school, and I think some of the students were involved in school sports or other extracurriculars involving physical activity that may have impacted the study. This was also a short duration for a study. I think it would need to be repeated several times to fully and continue to prove this. Recommendations for future research. Continued research of long-term daily amounts of vigorous exercise prior to math skills should be looked at. Possibly larger number of participants. Address scheduling conflicts immediately. I should track their exercise in and out of school. And then future research should also look at exercise routines before and during the study, or how could the type of exercise change the results of the study. These are my references, and thank you for being a part of my presentation.